In this lesson, I will explain to you support vector machine, how it works in machine learning. Before going to start, I will highly recommend please watch my previous two videos in which I had discussed the concept of support vector machine. Then it will be much more clear to you. Here I'm going to show you with the help of Python example. Actually what we have to do in this project to classify different species of iris flower using SVM means support vector machine. So what you have to do, first of all, you have to import pandas. You know that visualization and cleaning is one of the most important part of our project. After this, when we make the graph, it will be much more easy to understand which model we have to apply. So import pandas as PD, and then you know that import matplotlib.pyplot_splt for graphing purposes. Here you have to use this syntax from Sklearn data sets. You have to import load iris, right? This is the iris data set. As I have told you that after import, whatever you have to write here, you have to make the object and whatever name you want give to your object. I said iris is equal to load underscore iris. Exact you have to write down the same way. If you will use the uppercase, it will not work, and then use the parenthesis. I am going to execute it in few seconds. It will work. Meanwhile, we can discuss our next cell. So in our next cell, I have written to check iris data set. First of all, we have to check what is in our iris data set. For this purpose, you have to write down only dir and in parenthesis iris, because the name of our data set is iris. I am going to execute it. You will see these are the column names. So few column names I will show you. Rest of the column names you can see your own. So first of all, I want to see what is here, feature names. When I will execute it, you will see in our feature names, this one, sorry, this one, right? We have sepal length, we have sepal width, petal length, and petal width. On the basis of these, because you know that we have three different kind of species, how I know, I will show you next. So on the basis of these categories, these features, sepal length, sepal width, petal length, and petal width, we will differentiate our three different species. And then I will show you target. Target is our dependent variable. It depends on feature names. It depends on other feature as well, but these are the main features. So I'm going to execute it. You will see in target we have 0, 1, 2, 0, 1, 2. So what is the meaning of 0? What is the meaning of 1? As I said, we have three different species. I'm going to make this comment. So target names, see 0, 1, 2 is our target, which is our dependent variable. The name says that 0 means setosa. We have this kind of iris flower. If it says 1, 1 means versicolor and 2 means virginica, right? Okay, now we want to see what is in our data, this one, in this feature. So same thing, I have to write down iris dot data. Always you have to write down your data frame or data name first. So iris is my data, and then dot data. You can see to check the data which is in 2D. When I will run it, you will see the output of these, but these are in the form of 2D array. See, there are two square brackets. This is the 2D array. What is this column represent? What is this column represents? It means the first column is sepal length, this is sepal width, this is petal length, and this is petal width, right? But this is in the form of an array. I want to convert this array into my data frame. Before going to start, if I will say how many records I have in this array, see, it's too much. If you want to see, so you have to use only length function. Only you have to write down len and then iris dot data, because we are working on this, right? Data executed. So there are 150 records, different records. Some belongs to 0, some belongs to 1, and you know, right, setosa and other species or other kinds. To convert into data frame, this array, right, I'm going to convert. How? First of all, you have to assign some name. I said df is equal to pd. This is for, as we have imported pandas dot data frame, you have to write down as it is, d capital, f capital, and where you have to work iris dot data, and in columns, right, what should be the name of the columns? What I'm going to do here, I am converting this 2D array into the data frame, and I said I need these name at the top. So that is why I have used this iris feature underscore name, and feature underscore name as I have showed you already. So when I will execute it, you will see the output we have in the form of data frame. And why only 5 records? Because I have used the head function, right? So these are my 4 columns. Now to add target column, as I said, target is the dependent variable, and in target we have 0, 1, 2. I said I want to add my target column here in this data frame. Yes, you can do. How? This should be the name of my last column, which is I said target, from where iris dot data, and again I want to see first record, execute it. See, my target column is also there, 0, 0, 0. Why it shows only 0, 0, 0? Because these are only top 5 records, right? Okay, and this is the index. System generates this index, and index always start by 0. Iris dot target, I will show you what is in the target. I already showed this to you. There are 3 different items, 0, 1, 2, but it says 0, 0, 0 on the top first. If you will see this, right, this array, and if you will count, means the top 50 belongs to 0. This is Setosa. And then starting from 51, so 100, it is the second category, and onward is our third category. So if you want to check here, I can remove this. If you want to check only those records in which we have 2, the target is 2, so you have to write down df dot target equal 2, means we are going to apply some condition here. So see, 2 starts from 100. You can see from here, first is 0 and then 100, and then onward we have 2, 2, 2. So 100 to onward we have 2, 2, 2. Similarly, if you want to check only 1, I will show you 1. 0 is your homework. You have to check 1, right? Sorry, 0. So starting from 50 to 99, we have 1, 1, 1. Clear? If you want to check only top 5, 1, or I make it 0. If I want to check 0, right, 0 means Setosa, only top 5, then you have to use the head function. Execute it, you will see here. I will make it, this is 0, this is 0, right? Now your homework is, you have to apply tail function here, then it will give you the last 5. And if you want to write something here, 10, 25, whatever, this is your homework, because in this way you will learn if you will involve. Now to add a new column, I also want to add a new column. Here it says 0, 0, 0. I want a new column, flower underscore name as well, right? 3 categories. So this is the existing column. I am going to make a new column with the help of existing column. That is why we have to use the apply function. df dot target dot apply, and then lambda, right? You have to write down this syntax, iris dot target underscore name, and the name of our new column will be flower underscore name. When I will execute it, you will see now we have 2 columns. This is target and this is the flower name. Means 0 means Setosa. It will be easy, right? Otherwise it is difficult again and again. What is 0? Sometimes we forget, but only we have 3. 0 is Setosa, and then 1 is what? So I will show you here. df from starting from 35 to 60. I want to check this, right? So 35 is 0, because from 1 to 50 is 0, and then onwards. So if I will run this, you will see 0, and there are some records which are 1. Similarly, 80 to 120. So 80 to 99 we have 1, and 99 to onwards we have 2. I will execute it, so you will see. So first, second is the versicolor, Setosa, versicolor, and virginica. Now, in order to make our dataset easy, I will divide into 3 different parts. I said, see, here I am using the numpy feature. From 1 to 50, right? So 50 will not include, because it will start from 0 to, it will end on 49. The 50 is excluded. That is why I had started this one from 50. When I will execute it, now I have 3 different data sets. One is from 1 to 50 and then 50 to onward and this. Now I will see with the help of graph. Then on the basis of graph, I will analyze which model I have to use. So for sure we will use SVM because we are working on SVM here. So plt.scatter df0 means I am using this data frame and this data frame, sepal length, sepal width. On the basis of sepal length and sepal width, right, we are going to make some differentiation. So this one, and these are the labels. These are the labels. Here I have used color. Color is equal to red, marker is equal to diamond, same color blue, and so on. When I will execute it, you will see a graph, and see this is df0 and df1. If I draw a line here, right, if I draw a line here, I can very easily divide these two categories by using the hyperplane, because in FEM we use the hyperplane. And if diamond comes, we can say easily that it belongs to this group. If star comes, we say this belongs to this group, right? Easily we can divide this data into two groups. Similarly here is the petal length and petal width. Everything is same. If you want, you can see this coding. You have to write down exactly same. But here I have used G color. G means green, B means black. When I will execute it, so you will see again very clearly. If I will make my hyperlink from here easily I can divide these two into two different categories. It means that kernel is not working here, because when we have to apply kernel, if there is a misclassification, if these data are so close or overlapping, if I will make the hyperlink, we cannot divide these two classes easily by making a simple straight line. Then we have to use kernel, right? But here we are not going to use kernel, but I will show you. So now is the last and important thing. We split our data. So from sklearn dot model underscore selection import train test, we are going to train and test our data. And here, as you know, after importing this, we have to separate our dependent and independent variable. So in our data set, as I will show you one more time, here as I have added two more columns, target and flower name, this is our dependent variable, right? So we have to remove these two from here. So I am going to drop df dot drop target and flower name, and access is equal to column, you know, right? Because these are the columns, and I said this is X. When I will execute it, you will see the top 5 records, but these two columns are dropped. Now we have the independent variable. Independent variable, we need only Y. When I will execute it, you will see this is Y. Target is there, 000, Setosa is there. Right, okay. After this, we will apply test. So our test data is 0.20%. Total is 150 records. On 150 records, 20% I said I want to test, remaining 80%, and it will give this output. When I will execute it, it will execute successfully. Here, length X test, right? I will show you two, then you can apply this, run these two. So when I will execute it, test means 150 are the records, 20% of 150, which is 30. So on 30 records we are going to apply our testing, and then 120 we are going to train our data. Now from here, to create the SVM model, from sklearn.svm import, right, this one we have imported. That is why we have to create the object. This is our object. After this, we have to fit our model, X train and Y train. Now it is easy, right? From onward, I'm going to run this. See here, as we see, by default the value of C is 1, right? Same thing for the kernel. By default it is radio basic function. If you want to learn more about this, then you have to go just here or write down in Google sklearn.svm svc. Then you will see all the information, right? Parameters, this, whatever you want, you can read from here, and it will really help you if you will read. To check the score of the model, right? So model dot score X test and Y test, when I will execute it, it means my model is 0.9666% accurate, right? So we will test some prediction here. So it is 0.966. It will give us the correct answer. So here from x underscore test, we will take some sample data. So this is our sample data. See, it starts from 0. Randomly it will give. Every time you run it, randomly it will generate different numbers. So from, okay, I can check this one, right? 131. So 131, this is the sepal length, sepal width. If I will run this, so what should be the output? 2, because from 1 to 50 is 0, 50 to 99 is 1 and then 2. So I will check 131, right? And our accuracy is 96%, keep in mind, so it will give us the correct result, right? I will copy this model.predict and then see this 7.9 and this, right? This is the 131 record, which should be 2. Same thing, 82, right? The result of 82 should be 1. I can copy this and I will show you. Copy this and paste. Sorry, it was 5.8. Okay, this is 82. The output should be 1 because our model is 96% accurate. Now, as I said, the default value of C is 1, right? If I will change it, if it is C, I will execute it and see 0.96 accurate. If I will make it 4, so same. If I will make it 10, it means 0.966, right? Okay, make it this, because it depends, right? The value of this C changes. As I can make it suppose 30, sorry, there is no hard and fast rule how to set. By default it is 1, but when you will increase it is 9. This is so that this is fine. Same is for gamma. This is for regularization and this is for gamma. So I will execute if gamma is equal to 3.96. If I will execute gamma is equal to 1, so what is again 6. If I will make it 10.93, right? Or if I will make suppose 18, and so as the gamma value is increasing, the accuracy of our model is decreasing, so lower is better, right? And the concept of regularization and gamma I have explained in my last video. That's why I said it is highly recommend to watch that video. I will give the link in the description section as well. And now is the kernel. There are different kinds of kernel: linear, polynomial, radio basic, right? So by default it is radio basic. So I will show you here. We are not going to use this because clearly we can differentiate to our data. So this is all about the kernel. And if you want to check the score of the kernel, when I will execute it, as 0.96% accurate. So I hope the concept of support vector machine is clear. Please practice it, subscribe to my channel, and thanks for watching.